Hey, greetings and welcome. This is not the problem we're going to start with. We're talking about conic sections, specifically systems of conic sections, finding the intersections between multiple graphs. And we're on page 682. Here's problem 15. So first of all, analyzing this problem, I've got 4x squared plus y squared equals 25. And let's just figure out what conic this is. So first of all, notice the signs of my two squared terms are the same. Also, I have two squared terms, so that means it's not a parabola. Signs are the same, so that means it's not a hyperbola. And then the fact that the coefficients of those terms, 4 and 1, are not the same, that means it's elliptical. So this is an ellipse. And this equation here has no squared terms. It's got a y and an x. So this is a line, linear, right? So in order to solve this, it looks like if I do kind of a substitution technique, if I solve for either this y, which is probably the best choice, or this x, I'd be able to substitute in either of those and go from there. So let's do that. Let me subtract 2x from both sides. And I'll get y equals negative 2x minus 1 as my revised equation. And then I'll be able to plug this into y in the other equation, right there. So how many intersections between a line and ellipse could there be? What do you think?
Oh, 2.
Yeah, just 2. Just 2. Or 1, or 0. All right, so I plug this all in, and this is what I get. And hey, this right here, I'm going to expand that out using this pattern. A minus b squared equals a squared minus 2ab plus b squared. So I'd have 4x squared. A is the negative 2x, so this would be plus negative 2x squared minus 2 times negative 2x times negative 1, right? AB, yep. Oh, actually positive 1 technically, sorry. My formula already accounted for this sign, but it didn't account for that sign. So it's kind of weird, but. And then plus 1 squared equals 25. So let's simplify. So that's 4x squared plus negative 2 squared becomes positive 4. And x squared is x squared. This would become plus 4x plus 1 equals 25. So we can go through and combine like terms. Like so. So I'll have 8x squared plus 4x, and yeah, we might as well move this 1 to the other side. Well, yeah, let's do a completing the square technique. Because completing the square will work every time, and also we're probably pretty good at completing the square these days. So looking at this, I've got a quadratic. In order to solve, I'm going to complete the square. I'm going to take this 8, the leading coefficient, out of both of those. So I'll have 8 times x squared plus 8 times what is 4? It's actually 1/2 equals 24 blank, right? And let's see, let's find our new c term here. So that would be 1/2 divided by 2 all squared. So that's 1/4 squared, or 1/16. Oh, fractions are great. So let's see, adding 1/16 in the world of parentheses is really adding 8 times that, or 1/2. Right? I guess I could have divided both sides by 8 before I went too far, but that's fine. So let's see, this fast factors to be x plus 1/4 all squared equals 24 over 1 plus a half multiplied by 2 over 2. It's going to be 48 plus 1, 49 halves. I see a perfect square arising. To get rid of this 8, I would divide by 8. And dividing by 8 is the same as multiplying the denominator by 8. So this is going to be 49/16. A very convenient fractional perfect square. What do you know? So root both sides, plus or minus, don't forget it. So that's where sometimes our two answers come from. So I'd have x plus a quarter equals plus or minus square root of 49 is 7, square root of 16 is 4. Let's see, and I am definitely going to run out of room on this guy. Scribble, scribble, scribble. I'll come back to that problem later, perhaps, I hope. So, you can still see it? Yeah, that's fine. That's good enough. Minus a quarter from both sides. And I will have x equals, actually two solutions here. Either x equals 7/4 plus 1/4 is 8/4, or 2. Or I got x equals negative 7/4. No. It's not 8/4. I'm subtracting a quarter. Sorry. 7/4 minus a fourth is 6/4. Or 3/2, or 1.5, right? And then the other one is negative 7/4 minus a fourth would be negative 8/4, or negative 2. All right, so those are two possible x coordinates of intersections. So far it appears as though there will be two solutions of this system. So I've now got to find the corresponding y coordinates for both of these points. So where should I plug those x's, you think? Yeah, this one, the revised equation, is not a bad choice because it's already solved for y. So I'm going to plug them in here. Whoop. And all the way down. All right, so I'm going to plug both of those into the y equals thing. So over here, if I plug in 1.5, I'll have y equals, what was it, negative 2 times 3/2, or 1.5. And then what was it, minus 1 plus 1? Minus 1. And over here, I'll have y equals negative 2 times negative 2 minus 1. So I get y equals, the 2's cancel out, so that's negative 3 minus 1, y equals negative 4. And over here, 4 minus 1, y equals 3. So that means my solutions are 1.5 comma negative 4 and negative 2 comma 3. Yeah, 3/2 is cool. I usually like fractions better than decimals anyway. So, those are our solutions. Let's see, it says check your solutions by graphing each system. So, back up to the top. This equation is in a graphable form. Let me rewrite this ellipse in a form that can be graphed. I might be able to fit it over here. Well, no, I'll just redo it down at the bottom. Let's see, 4x squared plus y squared equals 25. Oh, wait. Guys, what am I thinking? We know how to graph ellipses. I don't have to graph it using technologia, right? We can figure out all sorts of stuff from that equation of an ellipse. Well, what I would do, though, is divide both sides by 4 here, and I'd have x squared plus y squared over 4 equals 25/4. No. I lied. I was kidding. I wouldn't divide by 4. I'd divide by 25 because it has to equal 1. So I'd have 1 y squared over 25. And the denominator for the x, well, I could have had it written as 4/25. All right. Or if I want to write that all as a denominator, which I would, I'd have to write that as 25/4 in the denominator, which is really weird. So that's kind of bizarre. So that means that, well, this is a vertically oriented ellipse. So A is equal to the square root of 25, which is 5. B is equal to the square root of 25/4, which is 5/2, right? And it also means that the center is at 0, 0, and it's vert, right? Right. And I don't need C in order to graph it. So let me get my coordinate plane. Let's see, 0, 0, negative 2x minus 1. Yeah, this should do. I hope. Yeah, what were my solutions at? Yeah, they're all close enough. So, to graph this, y equals negative 2x minus 1, my line. Negative 1 would have been my y-intercept. The slope is negative 2, so down 2 over 1, down 2 over 1, down 2 over 1. Or, conversely, up 2 backwards 1, up 2 backwards 1. And you could kind of use that as... kind of missed a bunch at the end there, but that's good enough for me. And for the ellipse, we said that its center was at 0, 0, right? It was vertical. The value of A was what, 5? Is that what I said? Yep. All the way up top. A was 5. So that means go up 5 from here. Go down 5 from there. Those are 2 of my vertices. And then the other one was 5/2, or 2.5. So over 2.5 and backwards 2.5. And so if I draw this ellipse, it'd be something like that. So my intersections occur there and there, which does that appear to be negative 1.54? Sure. Maybe. Oh, sorry. No. I just read that completely wrong, guys. Positive 1.5, down 4. Okay, so that should have been more around here. But yeah, if I drew that line in the right spot, it looks like it would have hit there. That's fine. Okay. So that's good. And the other one was negative 2, 3, and that does hit at negative 2, 3. Bam. So it appears as though graphically it makes sense, right? So here's the intersection of a line and an ellipse that hits at 2 points. 2 points. Okay. Let me take a look at 17 real quick, the no solution one. What does no solution mean as far as this goes? Yeah, they don't intersect. Let's see. There. So, looks like substitution is another good choice for this one. If I solve the top equation for x or y, I could substitute. I'm going to solve for y, I think. Just because this kind of plugs in nice there, but I guess it technically doesn't matter. So I'd subtract x from both sides, and then I'd multiply both sides by negative 1, flip the signs or whatever. I get y equals x. So let's substitute that in for y right there. So x minus 1 squared over 9 minus x squared, right? I just replaced that, equals 1. And I'm going to use the pattern to expand this. We could also get rid of the fractions first. Maybe I'll multiply both sides by 9. That's what I kind of feel like doing. So I'd get x minus 1 all squared, let's see, that minus 9x squared equals 9. And now I just got to figure out what this whole thing expands out to. because those 9's would have canceled out. So what does that equal to? That would be x squared minus 2x times 1 plus 1 squared. You might be wondering where I'm getting that. That's the same pattern we just used on the previous problem. So to expand the square of a binomial. So I'd have x squared minus 2x plus 1 minus 9x squared equals 9. And let's bring our squared terms together. Okay, so this is no solution. So I'm anticipating either my x's all cancel out, or when I solve, I'll get an imaginary answer. Let's see, I'll also subtract 1 from both sides here. So I'm going to get negative 8x squared minus 2x equals positive 8, right? Agreed? All right, so let's solve by completing the square. Let's factor out this negative 8. So I'll have negative 8 times x squared plus, what's that going to be, 1/4 x blank equals 8 blank. And well, I haven't been doing this that much lately, but let's say I want to get rid of this negative 8 before I completed the square. I could divide both sides by it. I just want to point something out here. So I'd have x squared plus 1/4 x blank equals 8 divided by negative 8 is negative 1. And if what I add here, all right, if what goes here is not big enough to make this side positive, when I factor this and I try to root both sides, if I have the square root of a negative, it would give me an imaginary number. So let's see if that's in fact what occurs. So to find my new c term, I'll do 1/4 divided by 2 all squared. Oh yeah, this is going to be too small. 4 times 2 is 8, so 1/8 squared. Okay, so 1/64, which is too small. So I would have that fast factors over here to be x plus 1/8. And negative 1 plus 1/64, well, I'd have to multiply this by 64/64. Nope, I just wrote that wrong. That denominator is still 1. Sorry. So I'd get negative 64/64 plus 1/64. It's going to be negative 63/64. And when I go to try to solve this, this is what I was saying, I get the square root of that, but it's a negative number. So I'd get x plus 1/8 equals plus or minus. Square root of 64 is 8, and square root of 63, 9 goes into that. I could break that apart. Let's see, what is that, 9 times 7? Well, I'd end up with an imaginary solution here. I'll show you. So square root of 9 is 3. I'd have 3i square roots of 7 over 8. Imaginary, because the square root of negative 1 is I. You guys remember that from Math 3? That's what the quiz my Math 3 students just took the other day is that exact concept. So I'd get that plus or minus 3i square roots of 7 over 8. But you probably could have stopped the moment you saw this, because you would just say no answer. Right? No intersection. Right? Or whatever you'd want to say, something like that. Right? Because I'm going to have an imaginary intersection between a line and a... Did we figure out what this was? This was a hyperbola, actually. Hyperbola. Let me graph this real quick. This time I might, instead of using my hyperbola techniques, I might actually graph this using other ways. So let's see. So the equation of the line was y equals x. This one, let me solve this for y. I'll graph it using technology because that'll be pretty cool. So I could have negative y squared equals, I'm going to subtract this whole thing from both sides. So negative of x minus 1 squared over 9 plus 1. And then I could multiply both sides by negative 1 to change the sign. Y squared equals positive x minus 1 all squared over 9 minus 1. And then how would I get y by itself here? Root both sides, right? Plus or minus, don't forget it. So I get y is equal to plus or minus the square root of x minus 1 all squared over 9 minus 1. So here's technically another equation of a parabola when it's solved for y. It's technically two equations because of the plus or minus. And let me show you what happens here when I graph that. So let's see. First of all, let's graph y equals x. Bam. So that's a line, right? There's our line. Slope of 1, y-intercept at 0. And then let's graph the square root of, let's see, x minus 1 squared divided by 9 plus 1. Looks like I've got the right setup there. So that's going to be the top half of this hyperbola. Uh-oh. Did I do this right? Yeah, it's supposed to be a horizontal hyperbola. What did I do wrong? Did I have a sign error when I solved it? Yeah, it's definitely supposed to be a horizontal hyperbola. Let's see, it's because I would have subtracted that whole thing. Yep. Plus 1. Changed the sign. And then rooted. I'm not seeing where my mistake was in rewriting it. Too early to think about this? But yeah, it should have been... So you think this should have still been negative?
Isn't that what it said?
No. Well, it did, but then I changed the sign because this was negative. Huh. I'm not seeing where my mistake was. That's sad. Yep. I'm not spotting it. Well, it should have been horizontal. I'll just draw it by hand. My apologies. So, let's see. The center of this hyperbola, I believe, is at, is it 1, 0? Yeah, 1 and 0, right? Yep. So center's at over 1, 0, right? The value of A is 3. The value of B is 1. So my vertices would be, and it's horizontal as we said, so it would be over 3, left 3, right? And the value of B is 1, so up 1, down 1. And then I draw my little box. And then I would draw the lines through those, which are my diagonals. So let's see, that's going to be like this. Oh my goodness. Terrible lines. But you get the idea. And then the graph would have been this here, right? And it wouldn't come to quite as much of a point as that, and that would look much cooler than that. This is a beautiful graph. All right. So so you can see that the line happens to pass through kind of the no man's territory of the hyperbola, right? So yeah, I don't know why my other one showed up vertical. I must have some sort of sign error there. If you're watching this YouTube video, you spot it, mention it in the comments so we could help other people out. So anyways, yeah, no intersection. Clearly that's a possibility. If the number of intersections I could have had one like that if it was tangent, you know, if it hit at exactly one point. I could have had 2, right, something like that, 2 that way, right, that way. But we are in the no intersections possibility. Actually, wow, that's really interesting. I could have had 2 like that. There's no way I could land it for me to hit 3. Because if it's steep enough to hit twice on one side, it's steeper than the asymptote, so it definitely won't make it over there to hit the other one. So kind of an interesting little, there we go. So anyways, I think that's all we'll do for today. I wanted to do another problem too, but this video is already long enough. So thanks for watching, friends. Bye-bye.